Hey, ladies and gentlemen, welcome back to Unit 4, Notes 5 on Zero Product Property and Applications. So we're going to jump right in and talk about, well, what is zero product property? So pause it here so you can write this down. All right, hopefully you have that down. Zero product property. When you hear the word product, you should be thinking the operation of multiplication. We are talking about two things that multiply, or more, two or more things, I should really say, that multiply to equal 0. So if part A times part B is equal to 0, then either part A has to be 0 or part B has to be 0, because 0 times B is 0, and A times 0 is 0. So what it's saying is if I'm multiplying two things, three things, etc., they are going to, one of them has to be equal to 0. So we are going to talk about them as binomials or trinomials. So we have here in our first two problems, part A and part B. So like x plus 6 is part A and x minus 4 is part B. So we would say x plus 6 is equal to 0. That says part A is equal to 0. So we're going to solve this, and x would be equal to -6. If I plug -6 back into my original problem, the x plus 6 times x minus 4, that would equal 0. Or my B portion could be equal to 0. So I'm going to solve that, so I get x is equal to 4. So either x is -6 or x is 4. Either one will give us 0. So we have to state both of those are possible answers. All right, so we would do the same thing here. This is a part A, this is a part B. So we set each of them equal to 0 and solve for x minus the 8. So 2x equals -8. Divide by 2, and x equals -4. So that's one possible answer. Then we set our other one, 3x plus 2 equal to 0. If I minus 2, I get 3x equals -2. And divide by 3, x equals -2/3. Oops, that's a silly 3. 2/3. So you could write that as -0.6 repeating. So it's fine to have it as a fraction or a decimal. So x will not always be a perfect whole number. All right, go ahead. I want you to try problems 3 and 4 by setting part A equal to 0 and part B equal to 0. And then I want you to pause the video while you do this and then come back and you'll compare yours with mine. All right, how'd you guys do comparing your answer with the correct ones up on the board here? All right, so now we look at these ones. These ones are not given to us in part A times part B, so we need to make them into there. Actually, this is looking very similar to the past few sections we did, specifically 4.3, factoring trinomials. So if you were to ignore this equals 0, hey, that looks exactly like what we've done. So the only new thing is now we have it equal 0. So we are going to treat this the same way we treated the trinomial. We're going to look for a GCF. This one doesn't have one. Then we're going to jump into our big X. So -20, +1. Things that multiply to -20 and add to a +1 are going to be a -4 and a +5. Because this is just a y squared and it doesn't have anything in front of it, I can use my shortcut. So I just go ahead and throw my factors in. And now my problem looks like all my problems 1 through 4. Why? I have a part A and I have a part B. So I can set each of these equal to 0. And I get y equals 4. And set part B equal to 0. And I get y equals -5. You can always check your answers by plugging 4 into y, plugging -5 into y. Both of those should end up with something that's a 0. All right, so let's look at problem 6. Is there a GCF we can pull out? There isn't in this one. So we're going to go ahead and we have to take 6 times -6. So we get -36 adds to a positive 5. When it multiplies to a negative, I'm looking for one negative and one positive. And when it adds to a positive, it means that my bigger number is going to be positive. And so if you know your facts of 36, we have a 9 and a negative 4. All right, I do have to do this one out all by grouping because the coefficient, the leading coefficient is 6. So I'm going to put minus 4p plus 9p minus 6 equals 0. So I'm going to group the first two and the second two. I pull out a 2p, and I'm left with 3p minus 2. 9p minus 6, I have pulled out a 3, and I'm left with 3p minus 2. All right, so same thing in the parentheses. Woohoo! We love when that happens. And then we put our leftovers into the other one. Now we have our problem at part A times part B equals 0. So I'm going to set each of those parts equal to 0. And I end up with P equals 2/3. And 2P plus 3 equals 0 minus that 3 over. And divide by 2, so I get negative 3/2. You could write that as negative 1.5. That works sufficient also. All right, so go ahead and I want you to try problem 7 and problem 8. So pause your videos and I want you to come back and specifically I want to talk about problem 8. Okay, so 7 was pretty nice because it was something we could use a shortcut on. 8, we had a GCF to pull out. Remember, always pull that GCF out, makes things way simpler. The numbers get smaller, we are easily able to find those factors. Now, I paused before I completed this problem. If we look here, we have 3 things. We have 2, r minus 3, and 3r plus 2. Now, we pulled out a GCF of 2, which is great. Now, that 2 does not have a variable with it, so I do not do anything more with it. I don't use it to solve for r. We would just set r minus 3 equal to 0. So we get r equals 3. And then we have set our 3r plus 2 equal to 0, and we get r equals negative 2/3. Now, we don't do anything more with that 2. I'm going to add a little slide here, and I'm going to show you 2. So this is what the last one just looked like. Plus. Okay, now if this said 2r, r minus 3, and 3p plus 2, now, because there is that r there, I do need to set all 3 pieces equal to 0 to solve. Because of that variable. That should not be a p. Sorry. Keep wanting to write a p from that problem before. R. All right, so I did that over here too, you guys. Sorry. So because there is a variable in the GCF, I do need to pull it out because remember, we are solving for our variable. Now, most of the time, that variable that you pulled out for a GCF is just going to be equal to 0. Not always, but most of the time. So here we end up with 3 solutions, which makes sense because if this part here was all factored back together, we would have 6r cubed as our first term. Now, our highest exponent is always how many zeros or solutions we would have. Now, if we FOIL this back together, we just get 6r squared. So it tells me I have 2 answers. This one is going to tell me that I have 3 answers. So keep that in mind. If I'm pulling a GCF out that does not have a variable, I don't need to worry about it once I get to solving for the variable. If it does have a variable that I'm pulling out, I'm going to use it to solve for my solutions. All right, so let's jump to the back side where we have word problems, some application. Now, we are going to talk a lot more about this type of function right here next unit, in Unit 5, where we talk about parabolas. You may even be talking about these or going to be talking about these in your physics class. So vertical motion. So when you kick something like a ball in the air, when you shoot a basketball, when you throw a rocket in the air, or shoot a rocket off in the air, you shoot a flare off in the air. They all follow this same type of path, and this curved path here in our graph is called a parabola. Okay, and the function that represents it is given here. H equals -16t squared plus vt plus s. Now t is time in seconds. That -16 will be included in almost all of our problems. That's gravity. That's the factor of gravity, what pulls it back down to Earth. Now, v is initial velocity. That's how fast something is kicked, shot off into the air, thrown, etc. And then initial height, that's when it's released. Now, if it's like a firework, it's going to be shot off from the ground, so our initial height would be 0. If you're throwing a basketball, you're going to be seeing that start at whatever your release point is. Okay? So if we look here, a flare is launched from a life raft. It has a height h of the flare in feet above the sea is modeled by that formula that's given to us, where t is time in seconds after the flare is launched. So we want to let h equal 0 and solve that function for t. Now, the reason why we want it to be 0 is because it says how many seconds will it take for the flare to return to sea. So when it gets back to sea level, it has a height of 0. Okay, now you don't need to write this. I'm just going to rewrite the order here to point out to you that this is given to us in the same type of form that we see here. We have our -16, that's our gravity. 100 would be our initial velocity, 100 feet per second, 100 miles per hour, etc. And then you'll notice that there's not plus anything, so that makes sense because it's being shot off from in the life raft, and that's going to be a height of 0. All right, so I'm going to go back to having it in this form, which is great. We don't need to even change it out of there. So we need to solve this. So as always, our first thing we look for is a greatest common factor. And in this case, our greatest common factor is 4t. So if we divide 4t out, we are left with 25 minus 4t. So this looks different than the problems that we looked at on the front, but we do still have a part A and a part B. In this case, our part A is just not a binomial, but that's not a problem. 4t equals 0. So if I divide by 4, 0 divided by any number is 0. So there's a possible solution. And 25 minus 4t. So we're going to subtract my 25 over. So -4t equals -25. So t equals 6.25. It is okay for decimals. Now, we have two solutions here, but only one of them is going to satisfy the question, how many seconds will it take for the flare to return to the sea? So the reason why we have two is if we go back here, the 0 is here. That's right before it's being shot off. At 0 seconds, it's still in the life raft. It's shot off, it hits a maximum height and comes back down, and then it returns to the sea at our 6.25. So we would not include 0. The 0 is a mathematical solution, but not a solution for this application problem. All right, the length of a rugby field is 52 meters longer than its width. So does anybody know what a rugby field shape is? It is, it's a rectangle. It's going to, ooh, let's change that color. It is going to be a rectangle. Now, just a reminder, don't draw a huge one. You need to save the space for writing, okay? Its length is 52 meters longer than its width, W. So they're telling us that the width is W and the length is W plus 52. Write an expression for the area of the field. Well, area of a rectangle is length times width. And then it tells us that the area is, so equals 8,160. So we are going to solve this to find the dimensions of the field. So we are going to distribute that W in. We need to make it equal to 0. We're going to factor it, and then we're going to set our parentheses equal to 0. It sounds like multiple steps. Yeah, these do get to be a little tedious, but none of it is hard work. It is all things that you are extremely capable of. So minus your 8,160 over. All right, so now we have multiplied that in, we've made it equal to 0. You always want to make your problems equal to 0. So we look at this and say, hey, do I have a GCF? I don't have a GCF. So then we do our factors, negative 8160, positive 52. Multiplies to a negative number, so I'm looking for a negative and a positive. And because we normally do not find factors in the 8,000s, I will help you out here today. We get negative 68 and positive 120. Now, if you had to do this on your own, I'm going to give you a little tip. Because this ends in a 0, I would start looking at factors that end in 5s and in 10s, okay, or zeros. So this has a 1 here, so I can use my shortcut. So W minus 68 and W plus 120. Now, just because I use the shortcut doesn't mean that you cannot do grouping. You certainly can. So we get each part equal to 0. W minus 68 equals 0. So W is equal to 68. And then we have W plus 120 is equal to 0. So we get W is equal to negative 120. All right, mathematically, both of these solutions are correct, but we do need to see if they are logical for our problem. Is it logical to have a distance, a width, a measurement of a negative number? It's not. So my width is 68, but it does ask me for the dimension, so I'm going to go plug that 68 back in to find my length of 120. All right. So, a pep rally is small footballs are launched using a slingshot. How long is the football in the air before it touches ground? Hint, H is when equals 0 is when the ball touches the ground. So we're going to throw a 0 in for H. And go ahead and look here. Is there a GCF that we can pull out? We can pull out a 2. So that makes this just a touch smaller, which is awesome. I am going to multiply my negative 8 times 3. Oops. So that gives me a negative 24 and positive 10. So two numbers that multiply to a negative. So you're looking for a positive and a negative. And in this case, we're going to have negative 2 and positive 12. So my awkward third wheel, called the GCF, tags along. Then I can't use my shortcut here. So negative 8t squared minus 2t plus 12t plus 3. All right, I'm going to go ahead and group. So first 2, second 2. Tag that 2 along. I'm going to pull out actually a negative 2. Oh, excuse me. I'm going to pull out a negative 2t here. So I'm left with 4t plus 1. I'm going to pull out of my second 2 a 3. So I'm left with 4t plus 1. Yeah, it's long. I get it. I know. I'm sorry. But you are all extremely capable of doing this. All right, so we're at this point here, and you are going to want to set each of those pieces equal to 0. Question, do you set the 2 equal to 0? No, it doesn't have a variable, so I don't need to do that. So 4t plus 1 equals 0. So I get t equals negative 1/4. And then negative 2t plus 3 is equal to 0. So I get t equals 1.5, or 3 over 2. So, question, those are both mathematically correct. Which ones work for my solution? Here we want to know how long is the football in the air before it touches the ground. Time, so we do not include our negative. All right, you got one more problem here. I'm going to ask you to pause the video here. I'm going to work the problem out, and then I want you to compare just to see how you did, just like you would do in class if I asked you to work on the problem on your own. All right, take a peek here. This one ended up a little bit trickier with the negatives in there. Notice I pulled out a negative 2t and a negative 1. And so then you end up with two solutions, 1 second and negative a half second. And remember, because we're talking about time, we can't have the negative 1/2. There you have it, ladies and gentlemen. Let you know if you have any questions.